Good morning, students. So today we are going to discuss about the question paper which is being conducted on 24th of this month. So observe the first question. Evaluate the indefinite integral. Evaluate the indefinite integral. And the question has been given as integration of dx by 4x plus 5. Here, as we are going to integrate this equation here, we are going to get 1 by 4 into log of 4x plus 5. So, option is 3. Observe the next question. Observe the next question. Observe that integration of dx by cubed root of x. So it can be represented as integration of dx by x to the power of 1 by 3. When we bring it to numerator, it can be represented as integration of x to the power of minus 1 by 3 into dx. So on integrating this equation here, we get x to the power of minus 1 by 3 plus 1 by minus 1 by 3 plus 1. So here we get observe that minus 1 plus 3 on doing LCM. Here we get minus 1 plus 3 by 3 by 3 minus 1 by 3. So here we get x to the power of 2 by 3 by 2 by 3. So on reversing this equation here, we get a 3 by 2 into x to the power of 2 by 3. So option is 4. Option is 4. And the next question is 28. Here, as you observe that integration of 2x cube minus x square plus 1 of dx has been given. We have to integrate this equation. As we consider that when we split the integration, here we can be represented as integration of 2x cube into dx minus integration of x square into dx plus integration of dx. So here when we represent the 2 outside, integration of x cube can be represented as x to the power of 4 by 4 minus integration of x square is x cube by 3 and integration of dx is x. Why? Because integration of x to the power of n into dx is equal to x to the power of n plus 1 by n plus 1. So here observe that 2 gets cancelled, choose a 4. So here we get x to the power of 4 by 2 minus x cube by 3 plus x. So option is 3. Option is 3. Let's observe the next question. 29th. Evaluate integration of x square minus cos x plus 1 by x into dx. When we split this integration, observe that integration of x square into dx minus integration of cos x into dx plus integration of 1 by x into dx. So integration of x square into dx, based on this expression, it can be represented as x 2 plus 1 is 3, x cubed by 3 minus integration of cos x is sin x plus integration of 1 by x into dx is log x. Since it is an indefinite integration, we add the integration constancy. So option is 4. Answer for this option is 4. Observe the next question. Integration of cos square x into dx. So since there is no integration for cos square x, here we can represent it as in terms of cos 2x, where we know that a cos 2x is equal to 2 cos square x minus 1. So when we bring this one towards this side, it can be represented as a cos 2x plus 1 by 2 is equal to cos square x. So here cos square x is being replaced with the cos 2x by 2 plus 1. Then the expression can be represented as integration of 1 by 2 plus 1 by 2 into cos 2x into dx. So here the expression can be split up as 1 by 2 into integration of dx plus 1 by 2 integration of cos 2x into dx. On integrating this equation here, we get 1 by 2 into x plus 1 by 2 into integration of cos 2x is 1 by 2 into integration of cos is sine 2x plus integrating constancy. So here we get x by 2. 1 by 2 into 1 by 2 is 1 by 4. So here we get sine 2x by 4 plus integrating constancy. So option is 1. Answer the next question. Here it has been given as a integration of 2 to 3 x cube minus 4x square plus 5x minus 10 into dx. So when we split this integration, observe that integration of 2 to 3 x cube into dx minus 4 into integration of 2 to 3 into x square into dx plus 5 into integration of x into dx within the limits 2 to 3 minus 10 into integration of dx. So based on the integration formula, x cube into dx can be represented as x to the power of 4 by 4 within the limits 2 to 3 minus 4 into x cube by 3 within the limits 2 to 3 plus 5 into x square by 2 within the limits 2 to 3 minus 10 into integration of dx is x within the limits 2 to 3. As we substitute the limits, Observe that 1 by 4 into x. The value of x is being replaced with 3. So here we get a 3 to the power of 4 minus 2 to the power of 4 minus 4 by 3 into 3 cube minus 2 cube plus 5 by 2 into 3 square minus 2 square minus 10 into 3 minus 2. And simplifying this value, here we get a minus 74 by 12. So option is 4. Observe the next question. Integration of 0 to pi by 4 cos x minus sin x into dx. So when we split this integration here, we can represent it as 0 to pi by 4 cos x into dx minus integration of 0 to pi by 4 sin x into dx. Integration of cos x is sin x within the limits of 0 to pi by 4, and integration of sin x is minus cos x 0 to pi by 4. So when we substitute the limits, here we get sine of pi by 4 minus sine 0 plus cos of pi by 4 minus cos 0. So here we get 1 by root 2 minus 0 plus 1 by root 2 minus 1. So here observe that 1 by root 2 plus 1 by root 2 minus 1. So 1 by root 2, 1 by root 2 can be represented as 2 by root 2 minus 1. Nothing but root 2 minus 1. So option is 1. Next, observe the 33rd question. Which of the following is a scalar quantity? The first one is electric current, second one is electric field, third one is acceleration, and the fourth one is linear momentum. As the electric field is a vector quantity. Electric field is a vector quantity, and acceleration is also a vector quantity. Why? Because it possesses a direction, and electric field also possesses the direction along with the magnitude, as well as a linear momentum. Linear momentum is also represented as a vector quantity. So the option is electric current. And we know that all the fundamental quantities are scalar quantities. So option is 1. Observe the next question. Here he had represented that which of the following is a vector? The options are given as energy, power, force, and mass. As we know that energy is a scalar quantity, and why? Because Energy is nothing but a capacity to do work, as work done is a scalar quantity and power equals work done by time. As we know that work done is a scalar and time is also a scalar, so power will also a scalar quantity. And we know that all the fundamental quantities are scalar quantities. So based on that, we can represent power is a scalar quantity, mass is a scalar quantity, as well as energy is a scalar quantity. Energy is also a scalar quantity. So the remaining option is force. So option is 3. Observe the next question. Identify the vector quantity. Identify the vector quantity. The options are has been given as work, time, heat, and angular momentum. As we had represented that work done is a scalar quantity, and we know that fundamental quantities are scalar quantities. So time is also a scalar quantity, and we know that heat is nothing but energy. As we had represented that work is equals to work done is equals to capacity to do. Energy equals to capacity to do work. So we can represent that it is also a scalar quantity. So the remaining option is angular momentum. Angular momentum. So option is 4. Next, observe the 36th question. Identify the scalar quantity. The options has been given as work, force, acceleration, and displacement. As we know that force is a vector quantity, and we know that force is equals to mass into acceleration. As mass is a scalar quantity, we can represent that acceleration is a vector quantity. And displacement, already we know that displacement is a vector quantity. Based on that, here we can represent that work is a scalar quantity. So option is 1. And observe the next question. Which of the following does not have the dimensions of length? So when we consider length, the dimensions of the length can be represented based on the units, where we know that 1 Fermi meter. Fermi is the nothing but it's a unit given for length based on meter, Fermi meter. And here we also know that micron. Micron is also represented based on the meter itself. Whereas Armstrong, and here the Armstrong is being represented as 10 to the power of minus 10 meters. As we consider all these conditions, and here the last option is a radian. We know that a radian is being given for angles. It has been given for angles. So it is not being considered for length. So option is a 4. It is being considered as a 4. Now observe the 38th question. Convert 1 Newton into dynes. 1 Newton into dynes. As we consider this condition here, as we observe that 1 Newton is represented as 1 kg meter per second square. And observe that 1 kg equals to 1000 grams and 1 meter equals to 100 centimeters. And we know that 1 second is equals to 1 second in SI system or CJ system. So here we are going to convert it into CJ system. Why? Because dyne is nothing but grams centimeter per second square, whereas Newton is nothing but kg meter per second square. When we replace kg with the grams, it can be represented as a 10 to the power of 3 gram into 10 square centimeter by second square. 10 to the power of 3 into 10 to the power of 2. Bases are same. So when we add the power, so 3 plus 2 is 5. 10 to the power of 5 grams centimeter per second. Nothing but 10 to the power of 5 times. 10 to the power of 5 times. So option is 2. Observe the next question. SI unit of pressure is. Observe that the options has been given as Pascal time per centimeter square, centimeter of mercury, and atmosphere. So here, as we consider this condition, pressure is being represented as a force acting per normal force acting per unit area. The SI unit of pressure is Pascal. So option is 1. And observe the next question. Newton per kg is the unit of. The options has been given as the velocity, energy, acceleration, and force. So here, as we observe that a force is equals to mass into acceleration, then acceleration equals to force by mass. The unit of force is Newton and mass unit is kg, or we can also represent it as Newton kg inverse. So the unit for Newton of per kg is given for acceleration. So option is 3. Observe the next question. The density of a liquid is 1000 kg per meter cube. Its value in a CGS system is. Here already we had represented that 1 kg equals to 1000 grams and 1 meter equals to 100 centimeters. Then the density can be represented as 10 to the power of 3 into 1000 is nothing but 10 to the power of 3 by 1 meter equals to 100 centimeters. So when we cube this equation on both sides, 10 square centimeter whole cube, it can be represented as 10 to the power of 6 centimeter cube. So 1 meter cube is equals to 10 to the power of 6 centimeter cube. Then the expression can be represented as 10 to the power of 3 and 10 to the power of 6 gets cancelled. So here we get 1 gram per centimeter cube. So option is 1. Observe the next question. If the units of length, if the units of length length, velocity, and force are halved. Then the units of a power is, as we know that a power equals to work done by time, where work done equals to force into displacement by time. But we know that a displacement by time is nothing but a velocity. As the force has been after, the new power can be represented as a F dash into V dash. The new power is given as F dash equals to F by 2 and V dash equals to V by 2. So when we substitute the values, observe that F by 2 into V by 2, nothing but FV by 2 into 2 is 4. So here the power can be represented as a P by 4. So observe that the power has been reduced by 1/4. So option is 3. And observe the next question. Here alpha has been given as F by V square into sine of beta t. Now we have to find out the dimensions of alpha and beta. Here V is a velocity, F is a force, and T is a time. As we consider that the maximum value of sine beta t is equal to 1, here we are going to represent that beta t is equal to 1. That implies beta equals to 1 by t in terms of dimension. So here we can represent it as t to the power of -1. As we observe that since it is a constant value, alpha can be represented as F by V square. The dimensions of force is given represented as mLt to the power of -2 by. We know that the dimensions of velocity is nothing but the displacement by time, nothing but Lt to the power of -1. Lt to the power of -1 whole square. So it can be represented as mLt to the power of -2 by L square into t to the power of -2. T to the power of -2 gets cancelled and 1 L gets cancelled. So here we get a m L to the power of -1. Observe that the dimension for beta is t to the power of -1 and the dimension of alpha is mL to the power of -1. So option is 1. Observe the next question. Given that S is equals to half F T cube. And here we have to find out the dimensions of F, where S is a distance. S is a distance and T is a time. T is a time. So based on that, here we can represent that F is equals to 2S by T cube. From this equation here, it can be represented as since 2 is a constant, the dimension for distance is L and time is t cube. So we can represent it as L t to the power of -3. So this is the dimension of F. So option is 3. Observe the next question. Given that dV by dt is equals to AT minus BV. Describing the rate of change of velocity of a body from rest in a resisting medium. The dimensions of A and B are. Now we have to represent the dimensions of A and B. As we know that the rate of change of velocity is nothing but the acceleration. So here we can represent that A is equals to capital A into T. Since AT as well as BV will be equals to this acceleration. So I'm individually equating the acceleration with the AT. Then A is equals to capital A equals to small a by T. So the dimensional formula for acceleration, it's nothing but L T to the power of minus 2. Then here it can be represented as L T to the power of minus 2 by T. Nothing but L T to the power of minus 3. And when we individually equate dV by dt with a BV, then expression can be represented as a dV by dt is equal to B into V. Then B is equal to acceleration. dV by dt is nothing but acceleration by velocity. The dimensional formula for acceleration is L T to the power of minus 2 by L T to the power of minus 1, where V is the velocity. Then observe that L gets cancelled and T to the power of minus 1 gets cancelled. So here we get T to the power of minus 1. So option is 2. Observe the next question. It has been given as a integration of 0 to pi by 2. 0 to pi by 2 cos x into dx. So as we observe this equation, integration of cos x is sin x, and within the limits 0 to pi by 2. As we substitute the limits, observe that a sine of pi by 2 minus sine 0. We know that the value of sine 90 is 1 and the sine 0 is 0. So here we get a 1. So option is 2. Also the next question. Integration of 0 to 2 4x cube into dx minus integration of 0 to pi by 2 cos x into dx. So here when we represent the 4 outside, why? Because the 4 is a constant, integration of 0 to 2 x cube into dx minus integration of 0 to pi by 2 cos x into dx. Already we had represented that integration of 0 to pi by 2 cos x into dx is a 1. As we integrate this equation x cube, here we can represent it as a 4 into x to the power of 4 by 4 within the limits 0 to 2 minus 1. Observe that 4 and 4 gets cancelled. When we substitute the limits, it can be represented as 2 to the power of 4 minus 0 to the power of 4 minus 1. 2 to the power of 4 is nothing but 2 to the 4, 4 to the 8, 8 to the 16. Minus 1. The expression has been represented as plus cos x. So here we get a 16 plus 1. So we get a 17. So option is 3. Observe the next question. The value of integration 0 to pi by 2 sine of 2x into dx. So here the integration of sine of 2x into dx can be represented as 1 by 2 into cos 2x within the limits 0 to pi by 2. So here observe that 1 by 2 into cos of 2 into pi by 2 minus cos 0. 2 into 0 is 0. So now here it can be represented as 1 into 2 and 2 gets cancelled. As we know that cos of 180 is minus 1 and cos 0 is minus 1. So here we get a minus 2 by 2. So here it gets cancelled. So we get a minus 1. So option is 2. Observe the next question. The number of significant figures in 0.01230. So now here we know that after the decimal point, we will don't consider the 0. So the remaining digits are 1230. So the number of significant figures is 4. And the next question is, here he had given that the volume of the sphere has been represented with respect to the error as a 1.5 percentage. As you know that volume equals to 4 by 3 pi r cube. And we also know that d is equals to 2r. Then r equals to d by 2. When we substitute this in this equation, the volume has been represented as a 4 by 3 into pi of d by 2 whole cube. So it can be represented as a 4 by 3 into 8 into pi d cube. So 4 2s are 8. So here we get a 1 by 6 into pi d cube is the value of the volume in terms of a diameter. Then as we observe this equation in terms of error, it can be represented as delta v by v into 100 equals to then d cube. Since r to the power of n, if we consider the power, then a delta r by r, if it is equals to some x, delta r by r into n is equals to delta x by x. So when we consider this equation here in terms of percentage, it can be represented as a 3 into delta d by d into 100. Nothing but a delta d by d in terms of percentage. It can be represented as a delta v by v in terms of percentage by 3. As the value of this change in the volume with respect to original volume has been given as 1.5, the expression can be represented as 1.5 by 3. Nothing but a 0.5 percentage is the change in density or percentage error measurement in the diameter. It's a percentage error in the diameter. So the option is 3. With this, we had completed the completed all the questions which are given in 24/6. Okay, Nana? Thank you.